Hello. Hi everyone, this is Prateek, and today we are going to start with the week 2 webinar, which is about descriptive statistics concepts. So I'll just give 2 minutes, so that everyone can join us, and then we'll start. Okay, so let's get started with the week 2 webinar, which is about descriptive statistics concepts and application scenarios. So in the business analytics nano degree, we have already talked about how do we interpret the data visualization to find out insights from that particular visualization. That is something which we did in the last week, and it was the basic thing which we did. Now we'll be moving to more complex, and more data analysis related skills. What we'll be learning, and this week we are going to learn about uh, statistics, and specifically about descriptive statistics. So before I start telling you about what descriptive statistics is, it's better we should know what exactly statistics is. So if I just go with the definition, statistics is a mathematical body of science that pertains to collection, analysis, interpretation, and explanation, and presentation of data. So basically statistics in short, it is a study of data. It includes descriptive statistics and inferential statistics. And descriptive statistics is basically the study of methods and tools for collecting data and mathematical models to describe and interpret the data. So as I just said, there are two types of statistics. One is descriptive statistics, and another is inferential statistics. So descriptive statistics is mainly, it is used for summarizing observations. Like we use mean, mode, median in that, and we basically these are the method of collecting the data so that we can visualize those data to the people. So that is what descriptive statistics is all about. But the second type of statistics is inferential statistics. So it is basically used for interpreting the meaning of descriptive stats. Basically, it can be used for doing predictions, or doing more complex thing, using the descriptive statistics to make sense out of it, or basically get to do something more complex than what we already have with the stats, with the descriptive statistics. So we won't be talking about inferential statistics in this particular course. It's mostly about descriptive statistics, as it is the basic business analytics nano degree course. And as a business analyst, you don't really have to work on inferential statistics. But yeah, if you're going for data analyst nano degree, or you're going for machine learning nano degree, there you're going to use a lot of inferential statistics. But since we have to study about descriptive in this particular course, let me get started with that. So in the descriptive statistics, we'll be talking about um, there are two things we can summarize the descriptive statistics into, which is one is central tendency, and another is the variation, which is also known as the difference within the groups. So if I talk about central tendency, central tendency is basically the value for a distribution. It may also be called as a center or location of the distribution. And the most common measures of central tendency are mean, median, and mode. So let us start with the central tendency, and then we'll move on to the variation part of descriptive statistics. So starting with the mean, mean is, mostly it is called as average. If you have 10 people earning in your company, people might be asking you, what is the average salary of those 10 people, or maybe there are different slabs in your office. There are workers, then there are VPs, then there are president, then there is CEO. So suppose there are 10 workers working in the company, and if you want to know the average salary, then you want to know about the mean of that particular those people working in that particular category. Then you can just ask what is the average of it. So yeah, most commonly it is also known as average, the mean. And it is only the sum of all the values in that particular uh, s- I'll say a sample divided by the total number of values. So the formula for this particular thing is y I divided by n, where n is the total number of numbers you have, and summation of yi is basically known as, it is basically the sum of all the numbers, and this value, the mean, is also known as y bar. So, if when you're doing the course on platforms like Udacity makes it really simple for you to understand what exactly mean is, and the formula is how does it work, how do you calculate mean. But if you're learning from some high school book or college level book, you'll find these kind of symbols there. Submission will be there, and then this y bar will be there, which might be a little confusing, but these are just a representation, and it might look complex, but these are really simple thing. So I'll just explain the particular formula to you. So y bar can also be represented as a y with a dash or a line above the y, which you can see in this particular slide on the first formula. So that is how you represent mean. Okay, the formula for that is summation of yi divided by n. So basically summation of yi here is the sum of all the values of y. If you want to find the mean of say numbers 1 to 5, which is 1 2 3 4 5, so you'll have to do the summation of yi, which is basically sum of all these numbers, which is 1 plus 2 plus 3 plus 4 plus 5, which will give you 15, divided by total numbers which are there, which is the value of n. And we know that we have 5 numbers here, so 15 divided by n, which is 5, which will give us 3. So the mean of those 5 numbers is 3. So this is what this particular formula and all these uh, symbols mean. So yeah, just to give a few more examples about mean. Suppose we have two classes, class A and class B, and we have 13 students in both the classes, and we say that IQ of these 13 students in class A are as follows. Like you can see 102, 128, 131, 98, and so on. And for class B, it is 127, 131, and so on. So if we calculate the summation of yi here, which is the sum of all the values, for class A, it comes out to be 1437, and for class B, it is 1433. And since we don't know the value of n here is 13, because that is the number of students we have, and when we divide the summation of yi with total number of students we have, we get the y bar or the mean as 110.54, and in the case of class B, it is 110.23. So we can say that the mean of the mean IQ of class A is little higher than that of class B. Mean can also be called as a balance point. So if you see, look at this particular example. Um, Say we have a seesaw which is 200 centimeters long, and we want to put a fulcrum somewhere at a point so that it becomes a balance point, and it doesn't, it's balanced, the seesaw is balanced. So, and we have three weights kept on our seesaw, the line we have 200 centimeter, and one or two of the balances, one of the balance, which is 1 lb, is kept on 93 centimeters. Another one is kept at 106 centimeters, and the last weight again of 1 lb is kept at 131 centimeters. So we need to find the balancing point here, which is basically the mean, so that balance on both the sides remains the same, and our seesaw doesn't bend any side. If we use mean here, we can find out that the value for the mean here is 110 centimeters. So if we put the fulcrum on 110 centimeter, our seesaw is not going to bend any side, and we will find a balance point. So that's why mean is also, we can also call it as a balance point if you want to. um, then yeah so there's this term called outliers, and a lot of people, a lot of students in our cohort reached out to me asking about outliers, what exactly it is, and they were not really clear with this concept of outliers. So I wanted to explain what exactly outlier is. So looking at this particular example, first of all, it says that means can be badly affected by outliers, and that is very true. And that is something you will understand once I explain what an outlier is. Now, suppose that you can see the diagram. It is relating to income of US. Okay, and now suppose we say it's not the whole US we are talking about here. We are just talking about a particular area, and we have only taken 1,000 people there. Now we say that out of these 1,000 people, say 998 people have a salary somewhere around $80,000 to $120,000. Um, and then there are two people, or there is only one people, one person, like Bill Gates is there in our sample, where we are trying to calculate the average income or the mean income of these 1,000 people, and Bill Gates is also in the list. So Bill Gates' salary is going to be way more than the people we have in our sample. So so if we talk about these 999 people, if their mean salary is somewhere around $100,000, for Bill Gates it is going to be around, maybe around $10 million or $20 million. I don't know, but it is going to be very different and much larger than compared to other 999 people. So if we include Bill Gates in our analysis to calculate the mean of that particular area, while calculating the average income of these people, then our mean is going to be, so if we have people with salary around $80,000 to $120,000, the mean should be somewhere around maybe $90,000 to $100,000. But if we are considering Bill Gates in our analysis, and his salary is like way more than these people, then the mean is going to be somewhere around maybe $500,000 or $10,000. So it is going to be much larger than expected. And this is what is known as outlier. This is a value which is directly affecting your complete analysis, and these are very few values. This is just one person out of 1,000 persons. So what we generally do when we are doing an analysis is we just make sure that these outliers are not there in our analysis, and we just remove these outliers by performing the analysis to make our analysis better, and make sure that that our analysis is not affected. The value of the mean, what we are trying to calculate here, should not be affected much. So that is what we do with outliers. We don't use it. We try to put these things out of the analysis. So that was about mean. Mean is like very simple to calculate, and it is something which we mostly use on day to day basis. Now, talking about median. Median is also known as the middle value of the number of values we have. So it can be called as the middle value, or it can be called as the 50th percentile, or 50% of whatever we have. That these are the general terms what we call, but in statistics we call it like median. So if I just take an example here to explain what exactly median is, if we talk about a class A, the example we took in the last example for while we were calculating the mean. So if we take the same class, we have 13 students here, and we want to calculate the median. So the first step while calculating the median is to first arrange all the values in ascending order. So that is precisely what I have done here. So IQs of different students were, it was randomly placed. Now we have, just we have put it in increasing order. And now, since there are 13 students, which is an odd number, we can simply say that 109 is the median here, because before 109 there are six values, and after 109 there are six values. So 109 is the middle value here. So this is pretty easy to calculate. But in case of even number, if we have instead of 13 students, say we only have 12 students. Now in the next example, what we are doing here is we are just removing one of the student who has an IQ of 89. Now we have 12 students. Now if we have to calculate the median value, um, it is done by taking the middle two values, which is basically the sixth value and the seventh value. And then we'll sum these two values and divide by 2 to find the median value here. So our sixth value is 109 here, and our seventh value is 110. So we'll sum these two values and we'll divide it by 10 to get the median. So this is how you calculate the median or the middle value for the numbers we have. And it is different for the case of if the number of values is even, or if the number of values is odd. So in case of odd, it is just the middle value. It's simpler to calculate. But in case of even, you have to take the sum of the middle two values and then divide by 2. So you get the median. So median, the median value is not exactly in the numbers you have, because in case of even number, because this is something which has been calculated. It is a new number which is not existing in our already existing set of 12 numbers. So median is something which is not affected by outliers. So the example which we were talking about in the last example, while we were calculating the mean, we know that mean is directly proportional to the outliers. It is directly affected by the outliers. But in case of median, that is not the case. If we are doing analysis on 1,000 people, the median is going to be, what we are going to do is we are just going to um, arrange all the numbers in increasing order. We'll take the 500th number, and that is going to be our 500th and 500 one number, whatever the salary of these two people are, and then we are going to divide it by 2, and that is going to be our median. So it doesn't really matter what is the maximum value here, what is the minimum value here. These outliers are not going to affect our median value. And yeah, so so that was about the effect of an outlier on median. Now let's talk about what our median value is going to be if we have a symmetric data or we have a skewed data. So basically, symmetric data means that the data on the left hand side of the graph and the data on the right hand side of the graph is like symmetrically distributed. But the skewed data is different. Skewed data basically means that some of your data, like most of your data is on one side of the graph and of the mean, and another some data is on right side of the mean. So basically the data is not symmetrically distributed in the graph. So that is what a skewed data is. So when we talk about symmetric graph, the mean is going to be in the middle, because mean is, as we know, it is the central value. We just sum it up and then divide it by the number of values we have. So in case of symmetric data, it is going to be the center, or we can say that the mean and the median is going to be the same. But in skewed data, as we said, that mean is directly affected by the outliers. So if the data is skewed, our mean is going to shift towards the larger number. But in case of median, that is not going to happen. And even in the case of skewed data, our median is somewhere in between of whatever number of data we have. So in median, the middle score or measurement is a set of ranked scores or measurements, the points that divides a distribution into two equal halves. And data are listed in order. The median is the point at which 50% of the cases are above and 50% are below, and it is also known as the 50th percentile. So this was a summary, about median, what we already talked about. Now moving on to mode, mode is quite different from mean and median. The calculation here is not uh, similar to what we did in the last examples in mean and median, but it is completely different. It is basically, mode is the most common point. So if we have, say, a data of 20 students, or if we have combined the IQ score of class A and class B, which is total of 26 numbers, we have 26 outputs, we can see that 109 is the IQ score which repeats most of the time. So we can say here that mode of this particular data, or mode IQ for class A and class B combined, is 109. And it is possible to have more than one modes. So since we have three repetitions here of 109, that is the maximum. That is why mode, right now the mode is 109. But had there been a case where 106 has been repeated three times, or 106 has been repeated four times, then in that case 106 would have been the mode. But in case of repetition of 106 three times, we would have been having two modes, 109 and 106. So that is what mode is all about. And again, in the case of symmetric data and skewed data, uh, mode is going to be the the center. So if we have a symmetric data, our mode is going to be the center, which is equal to the mean, the median. So that is what asymmetric data is all about. Mean, mode, and median, everything are on the center when we are talking about symmetric data. But in skewed data, it is different. Mode is going to be more towards it is going to be more towards the larger data we have, because as we know, mode is basically the number which has been repeated most of the times. So we can expect that in the graph, the number where we have lot of occurrences there, we are going to find mode. So yeah, that's about descriptive statistics. We have talked about mean, median, mode, and with that we are done with central tendency here. But now let's move on to variation, and what we have in variation. So as you can see in the variation, we'll be talking about there is range, there is interquartile range, then there is variance, and there is standard deviation. So we'll be talking about all these things one by one. Let's get started with the range. So range is basically the spread or the distance between the lowest and the highest value of a variable. you know um, like we were seeing the example of the two classes, the IQs of two classes in class A and class B. Now if we want to calculate the range of class A, or we want to calculate the range of class B, we'll have to take the highest value here and the lowest value, and subtract these two values to find the range. So here we can see the the minimum IQ of student in class A is 89 and the highest IQ is 140. So if we subtract these two values, we get the value as 51. So the range for class A is 51. But in the case of class B, the minimum value is 80 and the maximum IQ is 162. So if we divide these two values, we get 82. So we can say that um, the range for class B is 82. So yeah, that's about range, and let's talk about interquartile range. So um, interquartile range is basically a distribution of the data from the highest value to the lowest value. So there are quartiles. There are different quartiles divided in the range we have, starting with the first quartile, which is known as the 25th percentile. It divides the first, it divides the range into 1/4, and basically it divides the first quartile in 1/4 and the later in 3/4. So basically first 25% is in the first quartile, also known as 25th percentile, and the remaining one is in the 75th percentile. Then comes the 50th percentile, which is of course known as the median. Then comes the 75th percentile, and then there's the maximum value. So we have five values here, starting with the minimum value, the first quartile, also known as the 25th percentile, the median, also known as the 50th percentile, the the third quartile, which is the 75th percentile, and then the maximum value. So this is what interquartile range is all about, just dividing the range in different quartiles to make the representation, much easier and better. Now let's talk about variance. What variance is? So basically, variance is the spread of recorded values on a variable. You know, um, the larger the variance is, the further the individual cases are from the mean. So basically, if we have a higher range, for class A we know that the range was around 40, but for class sorry, it was around 60, but for class B the range was around 82. So we can say that the variance of class B was higher compared to the variance of class A. And yeah, the larger the variance, the further the individual cases are from the mean. That is something which is understandable, because if we are saying that we have a outlier, or our maximum value is much higher than our mean, then it is that far from mean. But if our maximum value and minimum value are close to mean, then the difference between the mean and the maximum value is not going to be much. So, variance is something people think is really complex to calculate, but it is very, very easy. Let me just demonstrate, give you an example to explain why I'm saying it is really easy to calculate. So, the formula for calculating the variance is, before calculating the variance, we'll be calculating the deviation, which is basically the difference between the number and the mean value of in that particular range. So the formula for calculating the deviation is yi minus y bar. So y bar is basically the mean, which we already know how to calculate, and yi is the value we are talking about here. So if we take an example, we are saying that the mean cost of a car is 20,000, but a person A owns, the cost of that car is 6,000. So the variance here, um, the deviation here is minus $14,000. So let me give a better example, which will explain what exactly variance is. So now suppose we want to calculate the deviation of 102, which is the IQ of one of the student in class A from 110.54. Now 110.54 is the mean value here, which we have already calculated for class A. So the mean IQ for class A is 110.54, and we want to calculate the deviation of the student with the IQ 102 and the student with the IQ 115. So what we have to do is we just have to subtract the value, the yi, with the mean value. So in the case of 102, it will be minus 8.54, and in the case of um, in the case of 115, it is going to be 4.46. So that is calculation of deviation. Now once we have calculated the deviation, when we square that deviation, we get the variance. So basically the formula for variance is yi minus y bar squared divided by total number of values we have. So I'll come to that. First, let's square the values what we have already calculated. So we know that the deviation squared for 102 is 72.93 here, and the deviation squared for 105, 115 is 19.89. So that is how you calculate the deviation. Now, if you want to calculate the variance for the whole class, we'll do the same for every single student. As you can see, we are subtracting 102 with 110.54, which is the mean. Then we are subtracting 115 with the mean, and so on for all the values to finally, we get the sum squared value as 2825.39. And then finally we are going to divide it uh, with the value n, which is the total number of repetitions, or n minus 1. So yeah, there's a catch here in variance while we are calculating the variance. um so if we are taking the whole population while calculating the variance, um, the formula is going to be the sum squared, which we have already calculated, divided by n. But if we are taking a sample from the population, the formula is going to be sum squared divided by n minus 1. So in our case, where we were calculating the class A value, which was basically a sample from the whole population. Um, so if we use that formula, we can find that our variance here is 235.45. But this value doesn't really make any sense to us, because as we can see, the IQ values of this most of the students here is 102, 128, 131, and this value what we have already, what we calculated right now, the variance 235.45, is nowhere close to it. So how this particular value is helpful to us, we want to understand that. So now for that, standard deviation comes into play. So if we want to convert variance into something of meaning, we use standard deviation. So standard deviation is basically the square root of variance. So what we have already calculated, if we square root it, we will get the standard deviation value. So if we calculate standard deviation for class A here, we can find that it comes out to be somewhere around 15.34. So and the average of person's deviation, so we know from this standard deviation that the average of person's deviation from the mean IQ of 110.54 is 15.34. So this thing now makes sense. So variance is something which doesn't make sense alone, but when combined with standard deviation, which when converted to standard deviation, it does make sense. And a few other points about standard deviation. So if we have a larger standard deviation, the greater amount of variation will be there around the mean. And standard deviation is going to increase if our range is increasing. And standard deviation can be zero in only one case, when we don't have different numbers. uh, Basically we have a constant number, so well, logically we won't be calculating standard deviation in that case. But in that case, it should be zero. And if you were to rescale a variable, the standard deviation would change by the same magnitude. If we change the units above, so the mean equal to 50, the standard deviation on the left would be 30, and on the right it would be 60. So, like the mean, standard deviation will be inflated by an outlier case value. Since, I hope you can understand that, because in the example you can see that standard deviation is 3 there, and standard deviation is 6 there, since our maximum and the minimum value are different in both the cases. So when we have increased the maximum and the minimum value, our standard deviation has also increased. So which basically tells us that uh, our standard deviation is directly proportional to the range. If it increases, our standard deviation also increases. So let's talk about a practical application of variance and standard deviation. So I'll give you an example. We all know that in this world where we pay real dollars for goods and services, um, most American employers, or per se any in anywhere around the world, the income is given, or the hike is given on percentage basis. But that is not the case when we have to do some payment. We have to buy something. So I'll be talking about this particular example. So yeah, why do you think that supervisors thinks that most fair raise is a percentage raise, and not just saying that we should be giving that particular employer a hike of $1,000 or $2,000, but instead what we say is we should be giving that particular employer a hike of 10% or 20% from whatever salary they have. Um, so but this particular system, there is an issue here, because let's talk about let's take an example here. Let's say there is this Seva toilet cleaning service, okay, and their salary pool is $200,000, and there are 5 people working in this company. One is the president, then the manager, the secretary, and the toilet cleaner. Sorry, 4 people are working in the company. The president gets a salary of $100,000. The manager gets a salary of $50,000, secretary $40,000, and the toilet cleaner $10,000. So if we calculate the mean of these, the salary we have, the mean is $50,000. The range, which is the difference between the maximum salary and the minimum salary, it is $90,000. If we calculate the variance here, which comes out to be 1,050,000,000, which is a very big number, which is basically sum squared divided by n minus 1. um, and if we see the standard deviation here, it comes out to be $32,400, which basically means that from the mean value, the difference is somewhere around 32,000 point $4. So that is a huge difference. If we say that we are giving an appraisal of 5%. um, so the 5% of our complete salary pool, which is $200,000, is going to be $10,000. Now if we divide the salary among the 4 employees we have, the president will get a hike of 5,000, which will become 100 $105,000. For manager, it will become he will get a hike of $2,500. So he will basically get $52,500. For secretary, it will be $42,000. And for toilet cleaner, his salary will increase from $10,000 to $10,005. Sorry, $10,500. So the toilet cleaner gets only a hike of $500 here. So, and if we calculate the mean of the new salary pool, which is $210,000, the mean is $52,500. The range would be somewhere around $94,500. And if we see the standard deviation, it has moved from 34.5 to 30. It has, yeah, it has moved from 34.5 to $34,000. So it also increased by 5%. So if we do the flat percentage raise, what we have done here, it is inequality, because if we see the top earner, or the president, he got 50% of the new money. So we added $10,000 new to this salary pool of $200,000, out of which 50% of this money, which is $5,000, has went to the president. But to the bottom earner, who is our toilet cleaner, he only got 5% of the money, which was allotted here. So this is basically not a very, you know uh, equal distribution, but hey, there is inequality here. That is why a lot of companies in US nowadays say that either you'll be getting a percentage increase, maybe a 5%, 10% increase, or you'll be getting $1,000 increase or $2,000 increase, whichever is the highest. So this is something, where variance and standard deviation application can be seen. So yeah, that's about variance and standard deviation example. And the example for mean, mode, and median is something I have already explained. So we have covered the central tendency, I mean mean, mode, and median of descriptive statistics. Here we have already also talked about the range, the interquartile range, and the variance and standard deviation, what are the application of these things, and how mean, mode, medians are being affected by the outliers. So I think that's pretty much it from about descriptive statistics. And of course we have a lot of amazing materials and videos, by Udacity, which you guys can go through, uh, and it will give you a much better idea about all these things. There will be examples, there will be quizzes to solve, which will in turn help you do better, get better idea of mean, mode, and median, and descriptive analytics. So before completing my webinar, I wanted to talk about box plots. So we have a lot of data visualization um, graphs. It can be a bar chart, it can be a line chart, it can be scatter plotting, and there are a number of data visualization graphs available. But this is one of the graph, which I think covers all the part of you know descriptive analytics, what we just talked about: the mean, median, mode, and the interquartile ranges, the 25th quartile, uh, the 75th quartile or the third quartile, the outliers. So this is something what box plot looks like. And you can see here the minimum value is 82. This is basically the visualization of class B, what we were talking about. So we can see that the minimum value, the minimum IQ value of the student in the class B is 82. The maximum is 162. um, our mean is 106.5. Our 25th percentile or the first quartile is 96.5, and the third quartile is 123. Since we did not had any outliers here, we don't represent it. But if we do have outliers, we represent it in the end of, near to the maximum value or the minimum value, with dots. Instead of the plain line, there will be dots. So if you draw this box plot, and um, if you want someone to understand all these variables, all the values of descriptive analytics, sorry, statistics, these they should be able to understand the everything, the interquartile ranges, the mean, mode, median, the outliers of the data what you want to share with them. So this is an amazing plot, and I would really like you guys to explore this more. And if you have any doubts, you can surely get in touch with me. And of course, I'll be sharing some materials, some good articles, and few awesome PDF books with you guys on the Slack channel. And yeah, then that's it from my side. If you guys have any questions, I'll pause for a minute. And if not, then I'm looking forward to getting more messages, more questions from you guys on Slack. All right, guys. So I think there are no questions right now. Uh, you guys can reach out to me, on Slack if you have any questions, any doubt in this particular webinar. And thank you very much.